Hello dear students, in yesterday's lecture we have studied regarding the free damped vibrations. We have seen some important definitions also, we have understood some concepts of free damped vibrations. Okay, so today we are going to see the general solution for free longitudinal vibration with damping. We will define some theory based on this free longitudinal vibration with damping. Okay, so you can see the figure of vibration system, in which in first figure you can see that in first figure there is one spring here, one damper you can see that here, and there is a mass at end position. Okay, in next right side figure there is a force body diagram shown to you. Okay, so basically what happens here, basically we all know that what is damper. Damper is a device which is used to reduce or eliminate the vibration which is produced in the system basically. Okay, same way spring, there is a stiffness K of spring and damping coefficient is C for damper particular. Okay, so now we are moving to force body diagram. Forces acting, you can see there is first force in downward direction here, it is force due to its load. Okay, then there is जो हम एक्सलरेटिव फोर्स जो लगाएंगे उसका अपोज करेगा mx डबल डॉट. देन देयर इज अ डैम्पर कोर्स cx डॉट, और ऊपर की बाजू हम देखेंगे रिस्टोरिंग फोर्स, जो स्प्रिंग को हम खींचेंगे, स्प्रिंग वापस अपनी पोजीशन पे आने के लिए जो फोर्स रिस्टोरिंग फोर्स लगाएगी, इट इज k डेल्टा x प्लस x. ओके, डेल्टा x प्लस x क्या है वो आपको भी पता चला जाए, क्योंकि वी हैव डिफाइन सो मेनी थियरीज बेस्ड ऑन दिस स्प्रिंग सिस्टम, मास सिस्टम. ओके, स्प्रिंग का ये इतना डिफ्लेक्शन है, आफ्टर अप्लाइंग द फोर्स और लोड इतना x डिफ्लेक्शन आ रहा है, सो इट इज डेल्टा x प्लस x. ओके, so that's why here it is k delta x plus x. Okay, good. So moving further, now here it is restoring force upward direction, damping force in upward direction, inertia force in upward direction, सब force दिखा है. ठीक है, now applying all the according to the laws, we are applying the rules, applying the forces. So we can say that mx double dot plus x delta x plus cx dot is equal to mg. Here there is an addition of cx dot coupled to free vibration without damping. Okay, so same way if we are simplifying the equation, so finally equation of motion for vibration is mx double dot plus cx plus kx is equal to 0. So generally equation is mx double dot plus cx dot plus kx. Okay, there is mx double dot, cx dot and kx, where we all know that x double dot is the acceleration, x dot is the velocity and x is the distance. Okay, so same way if we simplify these things, okay, so here we cannot directly get the solutions. Okay, फ्री वाइब्रेशन में विदाउट डैम्पिंग में हमको क्या मिला था, x डबल डॉट प्लस k बाय m इज इक्वल टू 0. So here we cannot get directly the value of omega n. Okay, so we are putting the general solution is x e dash to lambda t. Okay, if we are considering this, okay, this lambda is one symbol. Okay, t is the time here, x is the function of time t. Okay, so we are applying that x is equal to e dash to lambda t is the generalized solution. Okay, so उसको हम साथ सिंपल फॉर्म में लाके there is a equation, बाद में ऐसा इक्वेशन बनेगा that lambda square plus lambda, this is the finalized equation, where lambda plus c by m lambda, okay, plus x by m lambda is equal to 0. So this is generalized equation. So here we are applying the mathematical rule delta is equal to under root of b square minus 4ac, where a is equal to 1, b is equal to c by m and c is equal to k by m. Okay, so applying that rule, so equation becomes, तो उसका हमने रूट निकाल के उसका सॉल्यूशन आया. ओके, सो द रेशियो ऑफ c by m to k by m represent the degree of damperness present in the system Okay, it is known as damping factor. So now we are putting the value of damping factor equation. So we are getting the important equation of damping factor here. So it is zeta is equal to C divided of under root K by M. So we are getting two very important equation of free damped vibration here. C is equal to 2 zeta under root Km, 2 zeta omega n, and 2 zeta K by omega n. So remember these things, okay? So if the value of zeta is equal to 1, it is known as the critical damping factor. ये equation आप शांति से देखिएगा, mathematical terms से you will easily get this equation. Okay, so this is the finalized equation, general solution. We can say that three values, there are three cases after this equation. Okay, equation of motion is the mx double dot plus cx dot plus kx is equal to 0, while the general solution is x is equal to c1 e raised to lambda 1t n plus c2 lambda t2. और lambda 1 2 का इक्वेशन हमने ऊपर डिफाइन किया है, सॉल्यूशन किया आगे की थियरी में. lambda 1 2 is equal to omega n under root of 1 minus zeta plus or minus under root of zeta square minus 1, where zeta is the damping factor c divided by ct. Now there are three conditions we have studied in previous lectures also. Is greater than 1, it is zeta is greater than 1, overdamped system, zeta is equal to 1, critical damp, and it is less than 1, it is underdamped system. Now in next lecture we will see these three underdamped overdamped theories, and then we will solve example based on free damped vibration. If you have any doubt, please write in the comment box. Okay, we will discuss these three theories, overdamped, critical damp, underdamped, in the next whole lecture. Okay, if you have any doubt, please put comment in the comment section so we can discuss it there. Anyone can call me or can do WhatsApp also for this type of doubts. Okay, so go through this video, please watch full video. There are so many mathematical steps, so please do, when you are seeing this video, please take your pen and notebook with you, pen and paper with you, and try to solve this equation. And this is very important. Then we are going to discuss this thing. Okay, so hope you have studied this finalized equation of free damped vibration, longitudinal vibration, okay, with damping. Okay, so in next lecture we are going to solve example also based on this free damped vibration with damping. So thank you so much for attending today's lecture.